Hi. For our fourth lesson in this chapter on polynomials, we need to talk a little bit about dividing one polynomial by a binomial or one polynomial by another. Because unfortunately, not all polynomials can be factored. So we need to be able to tell if a number is a factor or if a quantity is a factor of a polynomial. So we're going to be dividing today. And like in any division that you do, if you don't get a remainder, that means you divided by something that was a factor. For example, if you divide 20 by 5 and you get 4 with no remainder, you know that 5 goes into it evenly. And that same thing works with polynomials. So I'd like to remind you of a method that you may have used in your Algebra 2 classes. The box method can also be used to divide. And as you look at the quadratic we're looking at, x squared plus 14x plus 45, we are going to try to divide it by x plus 9. So I set up a box, 3 terms here, 2 squares in my box. My divisor, x plus 9, is here. And we kind of had to work backward in order to do this division, since of course the box method is for multiplying. If we're dividing, we have to go in the opposite direction. So we know that the first term has to be x squared. We can place that in the box, folks. And then we work backward from there. In order to get x squared here, we had to multiply this x by another x. So I know that that x belongs there. Now I can fill in another square in my box. X times 9 is 9x. Okay, now we gotta think about this. We have 9x in there, but we need 14x. So if we want to make our 9x, when we combine like terms, into 14x, we need 5 more x's here. Do you see what we're talking about? Together, when we combine those like terms, we have to get 14x out of them. Now we can do the work backward thing again, because if this row has an x in it, then this must be a 5 up here. In fact, a positive 5. And to fill in the last square in the box, 5 times 9 is 45. Now, I want to look back at my polynomial. Oh, that's good. We needed 45, so we do have a factor. X squared plus 14x plus 45 can be found by multiplying x plus 9 times x plus 5. All right, I'd like to ask you to try that now. And we've got 4 terms in our polynomial here. So we're thinking we need 3 terms in our box. 2 rows, because our divisor has 2 terms. And here's what we're going to do. We're going to divide by x minus 3. We know that our first term has to be 2x cubed. So I'm going to put that inside, and I'm going to think, to get that 2x cubed, I had to multiply x by 2x squared. Now I'm ready to do a little multiplying here. 2x squared times negative 3 is negative 6x squared. I inspect my polynomial. I only needed negative 3x squareds, and I have negative 6 of them. So I have to add 3x squareds in order for my combining like terms to come out to the right thing. If this is x and this is 3x squared, then this must be 3x, because that's the only thing you can multiply by x to get that. Now we're going to multiply again. 3x times negative 3 is negative 9x. We go back to the polynomial and check. Hey, we needed negative 11 x's. We only have negative 9 of them, so we need minus 2x to go in this box. And working backward from there, x was already part of this, so we need a minus 2 up here. I'm going to go ahead and put my plus sign in there. Negative 2 times negative 3 is positive 6. And folks, we needed 7. So we didn't quite get there. Our remainder is what it would take us to get to 7. So we have a remainder of 1 when we divided here. That is, we needed 1 more to get up to that 7. I hope that you recall that from your last. All right, and what we can tell here is that x minus 3 is not a factor because it doesn't divide evenly. So x minus 3 is not a factor. All right, I hope that you remember that dividing by the box method. I'd like to take just a moment and have you try dividing by another method. In fact, we're going to do the same problem, and I just realized that I don't know the coefficients anymore, so I'm going to have to go back there and do a quick memorization here. 2x cubed minus 3x squared. 2x cubed minus 3x squared. 2x cubed minus 3x squared. 2x cubed minus 3x squared minus 11x plus 7 minus 11x plus 7. Okay, and we're going to divide by, or we want to check to see if x minus 3 is a factor. All right, so we're going to learn a method called synthetic division, and it's a little bit different. I've listed the steps for synthetic division here, and it begins with you list the coefficients in descending order. Okay, so 2, negative 3, negative 11, and 7. It says that you, and by the way, I notice I don't have this in here. To check to see whether x minus 3 is a factor, you divide by the possible root. So 3 is our divisor. I usually write the divisor out in front, so I'm going to put my 3 right here. And the rules say drop the first coefficient. So here's the first step. Here's the second. Drop the first coefficient. So 2 comes down to the bottom. It says then multiply. What you multiply by is the divisor. 3 times 2 is 6. Right? We dropped the first coefficient, then multiplied. The next step says add the product to the next coefficient. So 6 plus negative 3 is 3. Repeat that multiply and add. 3 times 3 is 9. Negative 11 plus 9 is negative 2. 3 times negative 2 is negative 6. And what we result in is that 1. I hope that looks familiar to you. What we just said is when you divide this cubic by this factor, x minus 3, possible root of 3, what you end up with is, remember we started at x cubed, the bottom part of this, those things become the coefficient in what's called the depressed polynomial. I know that sounds funny, but it is a polynomial of degree 1 less than what you started with. So 2x squared, right? We started with cubed, we're 1 less power of x because we've divided a power of x out of there, plus 3x minus 2 with a remainder of 1. I want to check that against what you got with the box method. 2x squared plus 3x minus 2, 2x squared plus 3x minus 2, remainder of 1. Ladies and gentlemen, synthetic division accomplishes the same thing, and many think that it's a little bit easier to work with. I'm going to ask you to try it. We are going to divide this polynomial by the factor, or possible factor, x plus 2. The rules say you start by listing the coefficients in descending order. We have 1x cubed. My note here, there is no x squared term. The coefficient then for the x squared, you have to use every place. That coefficient is a 0. The x term has a coefficient negative 7 and the constant was negative 6. To do my division, to see whether x plus 2 is a factor, I think about the possible root. If x plus 2 is a factor, then the possible root is negative 2. That's my divisor. Rules say drop that first coefficient, so we drop it down, and then multiply. Negative 2 times 1 is negative 2. The next step is add. 0 plus negative 2 is negative 2. Multiply. Negative 2 times negative 2, 4. Add. Negative 3. Negative 2 times 3, 6. Remainder, 0. Hey folks, that means that x plus 2 is a factor of our thing, and when you divide by x plus 2, we end up with the depressed polynomial. degree 1 less, right? So we have an x squared to start with, minus 2x minus 3. Those two things multiply together to equal our polynomial. And I want to write that here just so there's no confusion. X to the third minus 7x minus 6 is exactly the same as x plus 2 times this quadratic. All right, interesting procedure and one that we'll practice again, but I'd like to draw your attention to just a couple of theorems. The reasons why we're doing this is so that we can see if things are factors. And the remainder theorem very simply says, if a polynomial f of x is divided by excuse me, is divided by some binomial x minus c, the remainder is the value of the function at c. The remainder is f at c. So it's a quick way also to evaluate a polynomial for a given number. Do that synthetic division and it can tell you very quickly what the value of a polynomial is at a given number. The big news for us is that if we get a remainder of 0, that tells us that our divisor was a factor. And that's what we're looking for, a divisor that was a factor. So this is kind of an important thing for us as we're looking at solving polynomials. That's another practice problem. We have a polynomial equation here, polynomial function. We're determining if x plus 4 is a factor. If it's not, then we want the value of the function evaluated at -4. Why -4? Because if this is a factor, then -4 would be the root. So we're going to do that synthetic division thing. And we start by listing coefficients, 3, 4, -5, and 3. Our divisor is -4. And the procedure says drop the first coefficient, then multiply. Add and multiply, add and multiply. Oh, this one I gotta think about. I think that's 108. 4 times 7, 8. Carry the 2, yeah, 108, and it would be negative. Oh, y'all, we have a big remainder, -105. So x plus 4 is not a factor because we did not get a remainder 0. X plus 4 is not a factor. But f at -4 is equal to -105. And you can bear that out if you take a minute, pause the video for a second, and evaluate this polynomial at -4. You'll see that you do get that -105. That remainder theorem is pretty cool. A closely related friend, okay? The factor theorem. If f of x is a polynomial function, then if we divide it by some binomial x minus c and the remainder is 0, here's what we know. X minus c, if you get a remainder of 0, x minus c is a factor. If you divide by x minus c and the remainder is not 0, then what you know is f at c, is equal to the remainder. Okay, just two little tools that will help us as we're working with our polynomials. I'm going to advance to the next page and let's see how we apply this. So, it says solve the equation 15x cubed plus 14x squared minus 3x minus 2 equals 0, given that -1 is a 0. Well, y'all, if -1 is a 0, that gives us a great tool because we can do this polynomial division by -1 and we'll get a depressed polynomial that we can perhaps solve. So that's what I'm going to do. I'm going to set it up. 15, 14, negative 3, negative 2. I am dividing by negative 1. I think that, or I know that that is a 0, they told us. So we drop and multiply. Add and multiply. Remainder of 0, see? That negative 1 really is a factor. And here's what we're left with. 15x squared. Remember, that's 1 less than the degree that we started with. 15x squared minus x minus 2 equals 0. Folks, that's a quadratic, and we know how to solve every quadratic. The quadratic formula is probably going to be our friend here. So I'm going to say x will equal, it's the opposite of b. b is negative 1. So we're 1 over, and it's twice a. So 1 over 30 plus or minus, and then it's the square root of b squared. Negative 1 squared is 1 minus 4 times a times c all over 2a, so over 30. Let's see, I'm going to work out this way. 1 over 30 plus or minus, we're talking 4 times 15 is 60 times 2, right? That's 120. So it's 1 minus negative 120. 1 minus negative 120. Minus a negative, it's add. That is 121 under there, which is kind of good news because the square root of 121 we know. Our x's are going to be then 1/30 plus or minus 11/30, and we can do that math. So let's see. 1/30 plus 11/30 is 12/30, which reduces to 2/5 because 6 goes into both of those. X could also be 1 minus 11/30, and if we subtract 11/30 from 1, we get negative 10/30, which reduces to negative 1/3. And we have all 3 of the roots for this thing. 3, you say? We only see 2, but remember they gave us 1 to start with. So the roots are, or zeros are, they are negative 1, 2/5, and negative 1/3. That synthetic division is a wonderful tool. I hope you enjoyed learning about it, and we're going to be able to practice that a lot more when we get into our next class period. So please be sure to try the You Try tonight, and I'll see you in the next class.